Welcome students. In this video session, we are going to discuss about storage organization in the runtime environment. So from the perspective of the compiler design, the executing target program run its own logical address space in which each program value has a location. So during execution, this logical address will be converted by the physical address, and this will be taken care by the operating system in the target machine. So the management and organization of this logical address space is shared between compiler, operating system, and target machine. So as I said, the operating system maps the logical address into physical address, which are usually spread throughout the memory. Fine. Now let us see how the memory is being subdivided. How the runtime memory is being subdivided. Okay. So the storage layout of data object is strongly influenced by the addressing constraints of the target machine. Now these are the subdivisions we will be having in the runtime memory. Let's see it one by one. First we have code. So this is where the target code will be get stored. The given source code will be converted into target code, right? So the compiler will be converting into target code. So that target code will be stored in the portion called code. Then you have an area called static. So in this area, all the global variables will be stored here. So in this portion only, all the global variables will be get stored. In our program, we might be using some global variables. So those global variables will be stored in this static location or static portion. Now, apart from this code and static, we have two portions called heap and stack. The heap and stack are dynamic in nature. The memory allocation in heap and stack are dynamic in nature. During the program execution, the memory will be allocated and deallocated in heap and stack. Especially in stack, so specific to any particular function, a data which is specific to a function call, so that will be stored in stack. So whenever a function gets called or whenever a function is get activated, information will be stored in stack. That information will have details about the function that gets called, the local variables whatever we have used in that function, and lot more information about the function. So that is what called as activation record. So whenever a function gets called, an activation record will be placed in the stack. Suppose again if the function calls another function, say for example from main function we are calling a function called partition. So when the main function gets executed, an activation record will be placed in the stack. Now during the execution of the main function, if we call another function called partition, then another activation record will be placed in the stack. So for every function call, an activation record will be placed in the stack. The next comes heap. So if we allocate some memory dynamically during the program execution, if we allocate the memory, and those memory will be in heap. In C language, we have functions like malloc, clloc, using which we can allocate the memory dynamically. So those dynamically allocated memory will be in heap. Okay. So these are the subdivisions of the runtime memory. So the difference between stack and heap is the names local to a procedure are allocated in stack. Names in the sense the identifiers or the variables which are local to the procedure will be allocated or will be stored in the stack. And what about heap? The data which we want to be alive even during the different function call or different procedure calls. A control may go from one function to another function, or again it can go to another function like that. Even when the control leaves multiple functions, if you want to retain certain values, those value we can just store it in heap. A very good example is static variable. Static variable. Even uh, when we go to different function, the value of static variable can be retained. So such values will be stored in heap. Okay, so those values will not be removed once if the control leaves the function. It is not like local variables. In case of heap storage, the values whatever you stored in the heap, it will be available till the program is in execution. So that's about heap storage. Then, as I said, whenever a function gets activated in the sense whenever a function gets called, an activation record will be placed in the stack. Okay. Activation record will be placed in the stack. Okay. Fine. The next one is there is something called activation tree. So this activation tree is nothing but a representation of activation of procedures during the execution of the program. So during the execution of the program, how the procedures are get activated. So those activations you are representing in a tree-like structure, and that is what called as activation tree. Okay, so each node corresponds to one activation, and the root node is your root node refers to the activation of the main function. Okay, right. Now let us discuss with some example. Now you could see a program here. So in which we have a global variable called A. We have a global variable called A. Okay. Then we have defined a function called read array, which is used for reading 9 values from the user and store it in the array called A. So we have a function called read array, and we have a function called partition. Don't worry about the implementation of this function. It is not important from this point of view. So partition function, what it does is it just picks a pivot element and places the pivot element in some position. Here m and n are two limits. M is a lower limit and n is the upper limit in that array. Now what the partition function does is it just choose a pivot element and just places in some position. Say for example it is placing the pivot element in a position called I, and this I will be between m and n. So once if the pivot element is placed in the position I, so it means that the elements whatever you have left to it in the sense from m to I minus 1, they will be lesser value. They will be smaller than the pivot element. And those elements that is present in the right side in the sense those elements present in the array from I plus 1 position to n position, those elements will be greater than the pivot element. Okay. So ultimately it just places element in some position. Whatever element you have in the left side, they will be less, and whatever element you have in the right side, they will be greater. So in such a way, the element is being placed, and the position wherever it places the pivot element, and that is the result given by the function. So wherever position it places the pivot element, that position will be returned by the partition function. And then you have third function called quick short. And for this quick short, you are giving the lower bound and also upper bound. So what this function does is it just checks whether upper bound is greater than lower bound. If upper bound is greater than lower bound, you are partitioning the elements, and then again you are performing the quick sort for the left side set of elements, and then again quick sort for the set of elements present in the right side. So once if you do this the entire list of elements will be sorted in ascending order. Okay, so basically the implementation of quick sort is been placed here. Now in main function, what we are doing, we are just reading an array, and then we are giving some special values to the position where we don't have the actual values. We have the actual values only from a of 1 to a of 9. Then we are calling the quick sort function. Okay, so for quick sort function, we are giving the argument as 1, 9. So it means that the lower bound is 1 and the upper bound is 9. Okay, now let us see how the activation happens. So in this function, first the control enters into the main function. Once the control comes to main function. From main function, the control is going to read array function. And after executing the set of statement present in read array, the control is leaving the read array statement. Okay, so once after leaving the read array statement, next what it happens, it is performing, it's just executing these two statements, and again it is going for another function called quick sort. So the control is entering quick sort. Okay, fine. Now actually what happens is, once if the control comes to a function, or once if the function get activated, what happens is an activation record will created and it will be placed in the stack. So here for main function we'll be having an activation record, and for read array an activation record will be created and be placed in the stack. And once if the control leaves, in this case the control is leaving read array function. Once if the control leaves read array function, the activation record whatever is being placed in the stack, it will be removed from the stack. Okay, so when the control is in this point, you will be having only activation record for the main function. The activation record whatever that is being created for read array function, it will be removed from the stack. Then the control comes to quick sort function. So once if the control comes to quick sort function, what happens? In quick sort you will be checking this condition. Now in this case the condition will get satisfied, so control will be coming to here. So again what you're doing here, you are calling the partition function. So enter partition. Once after completing the partition operation, next step what you're doing, you are just leaving it. As I said, once if the control enters the partition function, an activation record will be created, will be placed in the stack. Then the control will be leaving partition. So once after leaving the partition function, next what happens? The control goes to quick sort of m comma I minus 1. Okay, so quick sort of 1 comma 3 in this case. Okay, so again recursively, again what happens? For this quick sort, again partition, then for left side again quick sort, and for right side again quick sort. So like that it happens. Okay, so once if quick sort of 1 comma 3 gets completed, then what happens? The control will be leaving the quick sort of 1 comma 3, and then the control will be entering into quick sort of 5 comma 9. What is 5 comma 9? It is a right side. Initially we said no, when the control is in main function, what happened? It is been partitioned, the pivot element is placed in some position, let it be I. So elements present in the left side of I, for them we have called the quick sort of 1 comma 3. Similarly for the elements present the right side, we have to call the function quick sort of 5 comma 9. This is for this lower bound and upper bound is for given set of input. Okay, we have given the value in such a way that the value remains like this. It varies for different inputs. If you give it some other set of input, probably the lower bound and upper bound may vary. Okay, fine. So quick sort control entering into quick sort, again it is leaving quick sort. Once after completing this, the control comes to the control leaves the main quick sort. Okay, so quick sort of 5 comma 9 leaves that here. And once after completing all the operation, the control will be leaving the main function. So this is how the different activation gets created. Now representing this activation by using a tree-like structure is what called as activation tree. You could see M you have a son, you have a child called R. What does it mean? So M is nothing but first letter of the function. Okay, R first letter of the function read array. Okay, similarly other functions. So M main function, from main function you're just going to read function, read array function. Once after completing it, then we are going for quick shot of 1 comma 9. So quick shot of 1 comma 9, for that what you're doing, you're just partitioning 1 comma 9. Once after partitioning, you're just going for quick shot of 1 comma 3, which in turn partitions again performs quick shot. Okay, so this will happen recursively. Okay, once after completing the left side of the position where we have the pivot element, next we want to process the element present in the right side. So for that again you have quick shot of 5 comma 9. So this tree will ensure sorting the list of elements in the right side. The next one is activation record. So procedure calls, returns are usually managed by a runtime stack called control stack, and during each activation an activation record will be created and will be placed in the control stack. So what are the things or what are the informations we will be recording in the activation record? In activation record, you will be having actual parameters. It means that you will be having the arguments for the function. If you pass some argument, that argument will be placed in the first position or first portion. Then in the next portion, you will be having the returned value. Okay, so whatever value the function returns, so that value you will be storing it here. Then you have control link portion. So here you will be placing a link to the calling function. So whichever function calls this function, say for example, main function has called a partition function. Okay, now assume that this is a activation record for the partition function. So partition function's control link will be pointing to the control link of main function. Okay. The next comes access link. If this uh, activation record needs data of different function, then it will be pointing to that function's activation record. Then saved machine status, here you will be having the state informations, the register values, whatever we have. So during function call and during return back of function call, these values are needed. Okay, so that is what saved machine status. Then you have local data, where you will be having all the local data in a function or a procedure. If you declare some variables and if you process something and if you store the values in those variables, so those variables will be allocated here, but those variables will be stored in this portion. And then we have temporaries. If our program handles some temporary variables, those variables will be stored in this portion. So these are the different informations we will be having in the activation record. Now let us see some examples. The activation record is also called as frame. Okay, fine. So when we call the main function, we have an integer array, and in integer array we just creating an activation record for main function. Then from main function we are invoking the read array function. So this is one activation record. Now we are just creating another activation record, and this activation record is for read array function. Okay, fine. And then once after completing the read array function, next what happens, the control goes to quick short function. So from read array function we are just moving to quick short function, and this portion refers to the activation record of the quick short function, and the above portion refers to activation record of the main function. Okay, fine. So similarly, when we complete the processing of quick shot of 1 comma 3, the control structure will be like this. So you'll be having activation record for the main function, activation record for the quick shot of 1 comma 3 and activation record of quick shot of 1 comma 3. Okay, sorry, here 1 comma 9 activation record for 1 comma 9 and here activation record for quick shot of 1 comma 3. There is something called a calling sequence. So calling sequence refers to the code which is responsible for creating the activation record and storing the information in the activation record. So whenever a procedure calls another procedure, the calling sequence will be get executed, and this calling sequence will be taking the responsibility of creating an activation record and storing the relevant information in appropriate fields in the activation record. Once after activation records gets created, then the record will be placed in the stack. And there is something called return sequence. So return sequence is another similar code uh, which is used for restoring the state of the machine. Say for example, just consider this case. Once if the control has gone to partition function, the partition function statements will be get executed. Once after completing it, again the control is coming back to quick shot. Once if the control comes back from partition to quick shot, whatever values you had in this partition function, they should be retained. They come back before going to partition function in whatever state the quick start is. In the same state it should be, right? So that is maintained by return sequence. That is possible because of the return sequence code. So return sequence refers to set of code which is responsible for ensuring the state between different function calls. Okay, fine. So this is how the different calling sequence are being implemented. So we have two activation records. One is a caller's activation record. Caller in the sense the main procedure. Okay, the main procedure which is in execution is what called as caller function. And from the main function, if you call some other function, that function can be called as callee function. Caller function and callee function. Okay, so in this example, the first activation record refers to caller's activation record, and the second activation record refers to callee. Now, throughout this discussion, we assumed that the top of the stack is residing in the bottom. So, any sort of insertion or removal will take place from bottom of the stack. Hope it is clear for you. Then, how we are going to have variable length data on the stack? So, what we can do is we can just have pointers. If you say, for example, in a procedure, you have a two-dimensional array, you have a local variable uh, called list. Assume that it is an array. But when we have an array, how many bytes you want to allocate for A, it will be known only during the runtime. So what we can do is, instead of storing the entire list element in the activation record, what happens is in activation record you will be having only the pointers to various data items, and these pointers will be pointing to the respective data item. So by this only variable length data are being handled. Thank you, students.